So now that a review of lines are complete at this point, we have a function in slope-intercept form, and we reviewed how to graph. The next thing that we did with lines is we fit data. So we were given some information. Like in the first one, we have a lake starts with a water level of 54 feet, and it is receding at a rate of a half foot per day, right? And so that information gives us enough information to find the line fit for that situation. Same thing down here, we have the average weight of a newborn girl is about 7.5 pounds, and for the first 6 months she will gain an average of 6 ounces per week. So again, we have some information to fit a linear function, and that's basically, let's go back and do the first one. That's my first instructions in this guy, right? We're going to find a linear function. I'm going to call L of D for the situation. In this case, L is the level, right? So I've given it a function name. We're talking about the level of the lake. And then what does it depend on? Well, it depends on what day that we're at. Each day it's dropping a half a foot. So it's actually dropping pretty fast. So what's the function? Well, again, we know, right, that what we want is 1/2 D, right? Oh, excuse me. I'm already coming up with the answer. What we know is we want to fit an M, in this case D plus B, right? Back in the day we called this f of x equals mx plus b. So we're just replacing the x with D and the f with L. And the slope is the method of movement. Well, that's that guy right there, right? This is a definite slope because of the per. So we're moving, or we're shifting, right, 1/2 feet per day. So my slope is a half, right? Each day we're going to multiply it by the number of days. And then what was my starting value? Well, when D is equal to 0, we have a level of 54. So essentially we have the y-intercept 0, 54. So that makes that 54. So there would be the linear function that represents the data that's given. And now that we have the function, we can answer some questions. So the first question is, when will the water level be at 30 feet? Well, right now what I gave you is a level, all right, and it's equal to 30. So I've given you the output. And so functionally that's what that's saying, right? When will L of D equal 30? Well, my L of D is given by that formula. So I basically have to figure out, oops, and by the way, that should be a minus 1/2, I'm sorry, because we are receding. So that means the water level's going down. If it would have been positive, that means the water level is going up. So my mistake there. So we have 1/2 D plus 54 equals to 30. And so now we just have to solve for the day. And we do that by subtracting 54 from both sides, right? That'll give us negative 1/2 D equals, I believe that'll be a negative 24. And right now, if I multiply both sides by negative 2, we get that D is 48, I believe. So according to this model, it's going to take 48 days. Let's make sure we get our units. So for this model, it'll take 48 days for the lake to go from 54 feet to 30 feet. Okay, so again, we're answering some questions based off the model I built. Next question, when will the water level be? What will the water level be in 100 days? So this time I'm telling you D is equal to 100. So in function language, we're finding, right, what is my water level at the 100th day? So this one's pretty easy, right? We can just plug in 100 and then do the calculation. Well, half of 100 is 50, and it's negative 50 because we are a negative slope. And then negative 50 plus 54 is 4. So the water level, right, on the 100th day, the water level will be at 4 feet. And, you know, that could be a good or a bad thing. Maybe we want to drain the lake, right, to dredge it out. It could be a bad thing, right, because we're suffering from a drought and we need water. So we can make those decisions later. But again, the flow, let's find our model. In this case, it was kind of easy because the y-intercept was given and the slope was given. So all I had to do was plug it into our nice slope-intercept form. Once I have the model, I can start answering questions, making predictions, finding values, etc., etc., etc. Right? So let's do this again. In the second one, again, we have the average weight of a newborn girl is about 7.5 pounds. Well, that is very much like a y-intercept. When the baby is born, the time that's went by is 0. And then we're told that for the first 6 months, so we're kind of have a restricted domain, she will gain an average of 6 ounces per week. And there's my slope. So M is 6 ounces per week. All right, now what we would like to do, right, so we got to find P of W. We usually start with the slope times my variable and then plus 7.5. And it would seem like we're done there, right, because that's kind of following the good old y equals mx plus b. But this one's a little tricky because you'll notice that the intercept is given in pounds and the rate of growth is given in ounces. So that model is a little off because this will be in ounces and that'll be in pounds. So we have to make sure that our units are the same. So we have a choice here. We can either change the pounds to ounces, or we can change these ounces to pounds. And I think that'll be a little easier. I think the going rate is 1 pound has 16 ounces. So that means what we're talking about here is 6 over 16 pounds per week. And I think that reduces to 3 over 8. So our model then, so everything is nice and even, we're increasing by 3/8 of a pound per week. We multiply that by the weeks we went, and we have 7.5. So there would be our linear model. So we had to be a little careful there because the units were off. Now that I have the model, I can go make some predictions. So how much will an average female newborn weigh in 32 weeks? Well, they're telling us that W is 32. So functionally speaking, we are being asked to find P of 32. So I plug 32 into my formula, right? 8 goes into 32 4 times, so that's 12. And then 12 plus 7.5, it looks like we're 19.5, and that would be pounds. So again, this is on average. So if the newborn baby is born roughly at 7.5 pounds, gains 6 ounces per week, then at a 32-week period, almost, what is that, like almost 2.5 months, the baby on average will be 19.5. Of course, some babies might grow faster, some might grow a little slower, but we are talking average. When will she weigh 30 pounds? Well, this time I've given you an output, right? P of W is equal to 30. So what input creates an output of 30? So we take our model, 3/8 W plus 7.5, and we set it equal to 30, and then we basically do our math. We subtract 7.5 from both sides, and I think that'll give us 3/8 W, and I believe that'll be 22.5. Multiply both sides by 8/3, and that'll be the trick. All right, and so how about I'm going to be a little, we got 22.5 times 8 over 3. And unfortunately, things don't go in real cleanly. So, we go to a calculator, we do some calculations. To save us a little bit of time, I'll go to a calculator on my computer here. I think 22.5 times 8, that'll equal 180. And then this is pretty easy, right? 3 into 18 goes in 6, so we're talking 60. So we are talking 60 weeks there, which I think is still within the 6-month time frame, all right? Or maybe not, right? So maybe that calls into question our answer that we had there at the end. But those are for statisticians to take. That's what my model is basically showing me. So it's about 60 weeks. According to this model, the baby will weigh 30 pounds, right? So hopefully that gives you a good introduction. Again, what made these word problems very nice is the fact that in the information, the y-intercept was given and the slope was given. Again, y-intercept was given, the slope was given, but we had to make sure we changed. But again, easy, because everything I needed in my y equals mx plus b was already given. So next video we'll talk about some situations where that doesn't happen, and how do we do and how do we fix it.